Should be working. All right, we are, should be right about on time, maybe a little behind. I don't know. Yeah, a little behind now. All right, so this week we're going to start talking about writing our own functions. We've been using functions, but now we're going to write our own. And why do we want to write our own functions? Where we can reuse code and not have to type it over and over again. So all those squares that you just had to type or write for your house and the window and all that stuff, and we had a draw square function where you just told it how big to draw the square and maybe where to draw the square, then you wouldn't have had to retype all those lines of code or copy and paste those lines of code if you didn't type them. But I want you to note some items before we get started. Project 1 and test 1 are next week. So next week will be no new content. My plan right now is for you to come in on Thursday and take the test. That way you don't get hit first of the week with a test. It gives you also Tuesday to come ask me any questions before you take the test on Thursday. But that leaves Tuesday free for us to go ahead and start Project 1. So I'll introduce Project 1 to you and get you started on the first part of it. I will not do the whole project in class, but I will give you a good start on it in class. And this is your indication that you should probably be here where you can code along with me and at least get a good start. I try to give a lot of the points in part 1 and then add more points from part 2. And then part 3 is kind of a challenge for most of my projects. So it's always good to have part 1 mostly written for you by the professor because you came to class and paid attention. Just saying. You will be able to get lab help from the tutoring lab, CSX over here, for part 1 and part 2 of my projects. Usually I tell them that they cannot help you with part 3 because it's where you prove to me that you know something or it's the challenge. It's usually 10 to 15 points the grade out of 100. So part 3 is not going to kill you if you don't get it done. But it gives me the opportunity to see, A, if you could do research, and B, if you actually understood what we did in class enough to apply it without hand holding. We all good? So I remembered rather late that I left off when we were supposed to be doing expressions on the first PowerPoint. We ran out of time. I didn't get finished. So I wanted to go back and make sure that we did that real quick. So we're going to do that first. And when I talk about expressions, I'm talking about the mathematical expressions for the most part and some comparisons that we're going to be needing to use. And they're typically the same mathematical operators that you're used to. There's a little bit of difference, So plus is plus, multiplication is a star, division is the slash. And they work just like regular math. They add, they divide, they subtract, right? Parentheses always come first, so your order of operations for math is going to apply. So parentheses, what is it? PEMDAS, parentheses, exponents, multiplication, division, adding, subtraction, something like that. We are going to add an extra one to your repertoire that you haven't been using in math that is mostly a computer thing. But so as far as with variables, though, involved, an equal sign, a single equal sign means assignment. I am assigning whatever's on the right-hand side to the variable on the left-hand side. So on this top one, I am assigning the number 3 to x. So now the variable x is holding the number 3. The next line down, it says x is equal to x plus 2. Well, that means that I want to evaluate the right-hand side first. So if I do that, x is currently 3. So 3 plus 2 is 5. I'm now going to take that and assign it to x, which means that I'm going to overwrite the 3. So now x is 5. Following me? Got some nodding. All right, so the next line says y is equal to x plus x. So x is 5 plus 5 equals 10. So y is now 10. We did not change x. So x continues on as 5. I'm just going to keep going unless somebody stops me. So now let's throw a monkey wrench into our basic math. And let's talk about modulo. So the percent sign is used for modulo. Modulo, or it often is called mod by people that have been doing this a while, divides one number by the other and returns or gives back the leftover portion or the remainder. Remember 3rd grade math when y'all had to learn long division and you put the whole number and then you had a remainder left over instead of a decimal place? They still teach math that way? I haven't been in 3rd grade in a long time. So in this case, if x is 16, we're going to do 16 divided by 5. Well, 5 will go into 16 3 times with 1 left over. So the answer for this one is 1 because that's all that's left over. Yes, ma'am.
What's the little sign that's between the x and the 5?
That's the,
I mean, the x.
that one?
Not that one, the other one. That one.
The percent sign?
Oh, that's percentage. I thought that was division.
So, if you use the percent sign, remember you're only going to get the leftover pieces. It's going to do whole number division and give you the leftover pieces. Now, if you want the reverse of that, if you just want the whole number without the leftover pieces, use 2 slashes or 2 division signs, and it gives you the 3 and throws away the partial. Yes? And somebody at this point usually says, why would I want to do this? Well, mod is used a lot when you're trying to decide if something's odd or even. Because if you return 1, it's odd. If you return 0, it's an even number. Also, it can tell you whether or not you're going to have any left over if you're trying to divide something into equal groups. The integer division will also tell you how many groups you would have, but it wouldn't tell you how many you had left over. So, you know, if you wanted to say, like this class has got 43 people in it. If I did 43 mod 5, then I would get back 8. I know I'd have 8 groups of 5. No, I get back 3. I would have 3 people left over if I put you in groups of 5. If I did the integer division, I could find out how many groups of 5 I have, but I wouldn't know that I had 3 extra people. Are we going to use this a lot? No, you might use it in this class to tell if it's odd or even. Will you use it in other classes? Yeah. As you advance more and more, but it's there. These are good test questions. What do these symbols mean? Right? 2 stars means exponents. So if I need to raise something to a power, I use 2 stars. So if I wanted 2 to the 4th, I would do 2 star star 4, right? Or in this case, if I got 2 and A is equal to 2 and B is equal to 3, and I do A star star B, it means that I'm raising 2 to the 3rd power. My computer in your way. I can. Just tell me. All right. Yes.
I was just going to ask, so for integer division, that's where you don't have anything left over?
Right. It won't give you any decimal places. It won't give you, you're just going to get a whole number back.
Okay.
No, there's stuff left. It just threw it away. The computer went, huh, they don't want those little fractional pieces. I'm just throwing them away. Anything not saved into a variable is just poofs away into the never of wherever. We call that garbage collection. It just cleans up the garbage that we don't need in memory. So you can check your types of operands if you want to. There is probably a function that does that. But if you get a error message, and you will get these error messages, it says something about unsupported operand or types, and it says something like int and string. That means that you have things on either side of that operand. One of them's not a number, because you can't do math on a string. Remember, we talked about that briefly when we were talking about data types. So if you're going to see stuff like this, because you're going to have variables that you thought that you used the right variable name, but you used the wrong one and it doesn't have, or you got numbers in from the screen. Anytime you use an input statement and you ask for a number, it's coming into the screen from the screen as a string, and we have to change it from a string into an integer. And we will be doing that as we move forward too. It's called casting. Yeah, like we cast a movie, we're going to cast our variable into a different role. We're going to force it to be something it's not. So functions do things. They are actions. So they print, they draw, they perform some sort of action or calculation, or that's the reason I call them the verbs of your problems. When you're reading a problem description, the verbs are probably going to be your functions. They return, or some of them do, some of them don't return anything. But if they create a value, they can return it. If they return it, you have to set the function equal to a variable. If they return something, they have to be set equal to a variable, like when we were doing input for name. We put name equals, and then we call the input function, because the function will run without the variable, but if you don't save what it returns to a variable, it garbage collects it. It does it, it returns it, and it erases it immediately. And this is a common mistake that beginning programmers do. They say, oh, I called this function. Well, yeah, you did, but you didn't save the result anywhere. So it ran, it did its job, and then it just discarded everything that it did. Yeah. So just be aware. So this week's new material is all about functions, right? So the purpose of functions is to do a task. A function should not do multiple tasks. It should do one thing, and it should do it well. Every time I press or I call input, I know that input is going to read a value from the screen. It doesn't read a value and print it. It just reads it in. Right? You should think about algorithms when you're coding, or plans for what you're going to be coding. That function should implement one or more steps of your algorithm, but it should only do one thing and do it really well. So we're going to draw square. We're going to create a draw square and draw triangle kind of functions as we move forward this week, because we know we've been playing with turtles, right? But my draw square is only going to draw a square. Now, when we get ready to draw draw a rectangle, technically rectangle could draw a square if you give it the same width and length, but it's also still a rectangle. It's just a rectangle that has equal length and width, right? If the definition of rectangle, a square fits the definition of a rectangle. A rectangle does not fit the definition of a square. So Just be aware. Now, there are huge benefits to being able to write your own functions, which I think you guys will see after you have done the assignment that's due tonight, and you've had to draw that pretty scene where you had squares all over the place, and so if you had a draw square that allowed you to just tell the function how big you wanted it to be, then you could have just called that function instead of having to write the lines and for loop every time to draw each square, right? You write code once, and then you reuse it, and you reuse it, and you reuse it, and you reuse it. The best functions are reusable, and they're not so specific that they only can do one thing, like draw square. If you hard coded in the width of the square, then it's not as usable. So to do a good function, we want it to be reusable and versatile. So we're going to talk about adding parameters where you can pass in information to fit the use you want to use it for. So the order of execution within a function is it does everything from top to bottom in order. Just like the code we've been writing so far. At the start of the function, it goes one line at a time from top to bottom. Now, does that function have to be in the order it's used in your code? No, you can define them wherever. But when we go to main and we call them, that's. So this is a function called move in a box. Basically, it's draw square. We're telling the turtle to move in a box without the loops, because I wanted you to see all the lines of code. So it's going to execute in this order, line 1 through 8. You will not type the numbers in your code, the line numbers. You can make the line numbers show in your code if you want to. I'll show you that too one day. So we declare this function very similar to the way we declared our main, right? We have def, the name of the function, which we're going to give it whatever we want to name it. I suggest you make it something useful and meaningful. If your function draws a square, call it draw square. If it draws a circle, call it draw circle. If it draws a triangle, do not call it draw circle. Yes. They will be called from main, but the function declarations are not in main. So, that makes sense so far? So functions can call other functions. Want an example of that? This move box function is going to call the forward function, the left function. So those are function calls inside of my function. This is where it starts getting confusing, and you have to start, your brain has to start thinking a little more outside of the box. No pun intended about my moving a box. When a function calls another function, it transfers control to that function. So, I told you we're going in order. So if we were to call the turtle's forward function, my code is automatically going to jump from there to the turtle code, run the turtle code. When it finishes, it's going to come back and do the next line. All this is behind the scenes. You won't ever see it make those jumps, but that's why we have to import that module. So it says, oh, I'm going to this module to get that code. So this is an example of 3 functions that call other functions. So they're different colors. So the dark red one up here is draw figure. This bright pink one is moved dashed. It's going to move in a dash line. And this one over here is turn left with a dash. Now, are we going to run these codes? No, they're for example purposes only. But this is three separate functions. But you notice that each of these functions is calling other functions, right? So the order of operation would look something like this. So draw figure is going to call or do the turtle.down function, put the pen down. Then it's going to move dashed. Oh, move dash is a function that I wrote, so it's going to go find it, and it's going to do all 4 lines of that code. And then it's going to go back up here because it's finished. So, and then it's going to go to line, this will be step 7, turn left with a dash. Okay, we'll have to go to that function to do that. So it's going to go down, start down to those lines. And then step 10, because it's not really lines, step 10 would be called move dash. So now it's going to jump back over here and step 11, 12, 13, 14. It's going to jump back to where it was called from, move down to the next line. Now this is finished, so now I'm going to jump back up from where it was called. So it's kind of like think about Chinese nesting dolls. If you go into one of the inner dolls, do all the steps there, you're going to return back out to the doll you were in. And then when you finish all the steps there, it returns back out to the doll it was in. I don't know a better way of saying that. Yes.
So when you're saying that it's calling the function, does it mean that it's like calling back, like telling it to go back?
Every time I say call function, that means it's going to go run the code in that function. So we've been calling functions a lot with our turtles. Every move, every left, every go to is a function call. Get my little handy dandy pen out. I don't know if this, I'm not going to write on it.
So is that why there was like 3, 11, 17? Because it's calling the function that was number 3 and 17.
So
I mean, 11.
we're going to try this. I'm going to try drawing this. So it's going to start here, right? And then it's going to go to 2. 2 is calling move dashed. So it's going to go from here to here.
Oh, so it goes from move dash to wherever it says move dash again.
So this is function number 1. This is function number 2. This is function number 3. Right? Every time you see the name of the function followed by the parentheses, that means it wants to access that function's definition and do all of the steps. So this one moves down to 4, 5, 6. Once it does 6, it jumps back to where it was at up here and goes to line 7. This one is calling move with a dash, so it's going to go from there to here. It's going to go to here, here. This is function number 2 again, so it's going to go back. Oops, follow my really strange line, but over there.
Oh, so that's why you go back to number 2.
Because no, it goes to wherever this is called. So everybody following me? Most of you following me? Some of you are just staring at it. All right, let's do this. If you've got it, give me a thumbs up. If you kind of got it, give me a halfway in between. And if you don't got it at all, put your thumbs down. I got a few that are halfway in between. Okay. So we're gonna stay here until we get it because this is important. You're not erasing race. There you go. All right. All right, let's this. So this is the name of a function. This is the name of a function. This is the name of a function, right? Def means I'm just defining the function. All the steps are going to follow after def. But when I decide to call the function, like right here, move dash, or choice of colors. If I call that, or I see that, that means that I am calling that function, right? Does that make sense? I want it to execute. I want that function to run at this point. So then I'm going to leave this function and go down to this function. Don't worry about the numbers. Just follow the arrows right now. And when I get here, I'm going to go in order the steps inside of here. Right?
Yes.
So all of these functions, I didn't write any new code for. They're just using the library functions. So we don't see it, but in the background, it's actually running back out to the library, running the code there and coming back. But we're never going to see it because we didn't write that code. After it's done the last step here, it exits this definition of a function and goes back to where it left from. And then our code continues on down to the next line, which oddly enough is another function call. So now I leave my code and I go over here. Oops. We're going to highlight her now. Right? So we leave here, we go over to here, we run these in order. Oh, wait, I've hit another function call. So now I've got to leave here and go back over here. Run these lines. When I leave here this time, I go back over here, move down. And when I finish this line, I go back up to here and do this line. This is a very chaotic diagram. But once you leave one function, you have to go to the others. Yeah.
Just gonna say, so it's the way that it's connected, like if it says dash and then you know that the other one says dash, and so you go back to, like for function 3, it says def turn left with the dash. Is that why you know to go back to def move dash function 2?
Yeah, you look for the names. The names are going to match. If you see move dash, it's going to go to move dash. If you see turn left with a dash, it's going to go to the definition of turn left with a dash.
So whenever
Whenever the computer or the IDE sees the name of a function, it's going to search your code first for the definition of that function. If it doesn't find it, it's going to go to whatever you imported. Or if it's a turtle, it's going to say my turtle.down. Well, we told it in advance that you're going to a turtle file because a turtle called the function. If there's no variable name or object name in front of it, it looks internally first and then it moves backwards through your folders, which is a little more complex than I wanted to get for this particular class, but it is how it works. We're going to talk about scope in a minute, but people that have had other programming languages are all giving me that look of pity that I'm having to fix and explain all this because it's hard to wrap your mind around. Don't hesitate to ask questions. This is not necessarily an easy concept to wrap your mind around. I wouldn't spend this much time on it if it wasn't. All right, so let's jump back into the presentation. I'll be happy to come back to this. If you individually need more explanation to it, just let me know. But for this time sync right now, let's go ahead and go through the rest of the slides and we can do this individually if we need to. Or you can ask your neighbors. Some of them are really nice and they're great at explaining things. Some of them do a better job of explaining it than I do, which is fine. Does not hurt my feelings at all. All right. So a function definition, like I said, starts off with the keyword def for definition. Whatever you're going to name it. Remember, you can't have spaces in it. It has to have underscores. And then the parentheses, open parentheses, and now I have a word in there that says parameters. Parameters could be 0 to none. It's usually a list separated by commas if you have more than one of information that the function needs to run. So like my example earlier when I was talking about draw square, if I wanted to tell the square every time how big it's going to be, the parameter might be size or width, however works best for you, right? So then once you're inside the function, just like main and just like your for loops, indentation is what is the key factor for defining what's inside the function. Put the colon on the end, hit enter, it'll tab over, make sure every line that's in that function is at that same indentation mark or further in. Otherwise, it doesn't belong to the function. So in this one, we have def, display info, open parentheses, name, comma, message, close parentheses, colon. So red is the name. Blue are the parameters. This one has 2 parameters. When I go to call this, like when we do forward, we give our turtle a distance, right? We gave it a parameter. We gave it a value. So you have to either give it a set value or you give it another variable that holds the right value. That makes sense? Yes.
So like when you define main, are we putting these in or like functions in main or?
So that's a very good question. He asked if we were going to be putting these functions in main. No, we're going to call these functions in main, but every definition should not be inside of main. So DEF with main, and then your definitions will all be at the same indentation point, which is on the left-hand edge of the screen. If you indent them in, then you have functions inside of functions, and you get something we call recursion going on. And that's not necessarily a great idea because it could go wonky very fast. And it makes it where you can't use. If you define a function inside of a function, then that function is not visible to the other functions in your program. Like the for loop. The for loop belongs, the stuff inside the for loop belongs to the for loop. The stuff inside of a function belongs to that function. So if you put another function inside of it, that function belongs to it. This absolutely gets easier with practice, I promise. But we have to cover the terminology and the theory behind it before we can practice it. So when you're defining it, you pick what you want these variables or parameters names to be. Make them descriptive because you will forget what X, Y, and Z are unless you're dealing with something that has X, Y, and Z coordinates, then that might make sense. But if you're just putting a letter in, like you put N for name or M for message, you might forget what that means. And we want them to be reusable. So you want to be able to copy these functions into future code where you don't have to rewrite them, right? So whatever, when you call this function, whatever is in name and in message will print. So print hi, name, print message, message. So it's going to take user or system input and plug it in. So this function to display info will work for every person in here because when I call it, I'm going to tell it which name and which message to print. Like when you ask in your code for the person's name, their favorite hobby, those things, it was stored in a variable. That variable could then be passed into display info, and it would change every time the variable changed. Yes, ma'am.
I was just gonna ask, why is it that when it prints it comes out as hi name when it doesn't say hi in the blue?
It's going to, when, by this definition, it's going to print whatever's in the blue. This is not actually what's printing. This is the directions to the computer. What's going to print is whatever, when the program runs, gets assigned to name.
So
Yeah, you're going to fill it in later. So this is just a piece of your finished code. So when I go to call display info on this slide, these down here at the bottom are the actual function calls. Because I don't have def in front of it. I just have the name. And then I gave it Bob and I gave it good day. So Bob now goes into name. So when I go back to the definition, everywhere name is, it's going to put Bob. Everywhere it says message, it's going to put good day. The next time I call it, I put Sue and hello. It swaps out Sue for name and it puts hello into message. Yes.
is there a time? This is like this specific, I guess, just like, is there a time where this is useful outside of the user input?
Yes. So when you get ready to start drawing your train, you're going to give it locations. And you're not going to ask the user for those. You're just going to give them to them. Anytime you're running code that needs to do a calculation, you could pass it in the numbers. So you could set the formula up into a function and then just give it the numbers every time. So there's a lot of applications where this is useful. The one we've used so far has just been input statements and the forward and go tos of the turtles. So go to had two parameters. It takes an X and a Y. Forward took a distance. So parameters are very, very useful for functions because a lot of times functions need more information to run. Functions can have what we call return values. So if it created a piece of information or a piece of data for you, it did some math for this for an example, and you need to get that number back out to use in your program, then you would have a return value. And you would have a line that was just, that starts off very simply as return and then whatever you need to return. In this case, this function is going to take two parameters. It's going to take A and B. And then it's going to add A to B and put it into sum. Right? And then it's going to return the sum divided by 2. So it did some math and it's sending the answer back. So if we have a function, and this top function up here does one thing, it just returns the size times steps. Just a second. I don't want you to sit there with your hand up. Just give me just a second. So all this function does is multiplication on two numbers and return the value. Pretty simple function. So when I get ready to call it, I'm going to create myself a variable. In this case, I called it result because it's going to be the result of whatever math happened. I'm going to set it equal to the function call with the numbers I want the math done on. And then I'm going to print out whatever's in the result. So what this does when it gets down to this portion is just